We're going to do problems from paper 2. It's highlighted here. I'm going to do from paper 2 from JEE Advanced 2025. And we've been doing paper 1. We completed it. We're doing a little bit detailed calculation, not talking too fast, just slowly, so that I'm trying to make everything clear. Okay, so here is a question 1. And this is a dimensional analysis question. You can see all the dimensions. Okay, and so there's things over here. S is, it says EMF over temperature difference. EMF over temperature difference. Okay, so EMF is just voltage, and temperature difference is just K. All right. So voltage is none of the fundamental units that given for us. So we need to convert that. Maybe we can do like I times V, and we can do I. First, we should do it so that we can simplify this stuff. And I mean, there's one way to do it, is this: find all the way, you can do all the way to get to the unit that will give you basic units, and then to the sigma, get all the way to the basic unit, kappa all the way to the basic unit, right? But I'm not going to do it that way. It's just so this is just power, so we can always express power in basic units. Let's see if we don't have to do it, maybe. And you have K and I, so this will get to the basic unit. Let's hold off on that. Let's see, there will be some simplifications. Sigma, where will it come from? It will come from resistance is resistivity. So sigma is 1 over resistivity. So let's write this 1 over sigma. Resistance is parallel to the length of the wire divided by the area of the wire, which is same as length square. So 1 over sigma L. So this gives me sigma is equal to 1 over RL. Well, let's multiply R by I and divide by I, so that I can go to the voltage RL. So you have an I over VL. Well, multiply again, I get I square over VI. So this can idea is to get to see if we can cancel out some of this. So we do get I square over PL. Okay, so that's pretty good. And the kappa, what are we going to get kappa? So this is all fundamental now. I can just, you can see power is going to be joules over time, and joules will be Newton over length over time. Newton will be mass length times the -2 over L length over time. So mL squared to the -3. So power can be like that, but I don't want to put it yet. Maybe just simplify, then we'll see. Kappa, let's write it so it's not, it looks a little different, like a script A or something. This will come from, you remember, heat over time. If you look at area A and length L, and this side kept a temperature T1, that's the temperature T2, and it's the kappa. The question is how much heat is going to transfer from this end to that per unit temperature, per unit time. So this will be proportional to the area, proportional to the delta T, T1 minus T2, and inversely proportional to the length. And this script, this kappa is going to be proportionally constant. So from there I can, of course, we can just get rid of this, and this becomes L, just units, not length. This is A will be length square. So you can say length square, unit cancel out. So that from here we see kappa is going to be, so these will go downstairs. You have a joule over time, joule over time. There's the watt, there's the power. So let's call this power. So power divided by L and delta T, that's the temperature. It says use the K for the temperature, unit Kelvin. So kappa looks like this, sigma looks like that, and S looks like that. And let's see, we put in there just those little formulas, see what's gonna turn out. I bet it's going to simplify. It's so complex, if you put out just the fundamental things right from the get-go, it's going to look very complicated. So let's just see how far we get. So Z is called S square sigma over kappa. So this is P over L temperature, and let's see, is going to P square over K square I square times I square over P times L. I square cancels out. This will invert, so let's make sure we're not, one of the P's will cancel this guy. So I have a P over K square L, L times K over P, inverting that guy. This, wow, everything got cancelled out, so it's like 1 over K, that's the unit. So K to the power minus 1. Looking over here, this is everything else, no units. That's going to be B will be the correct answer. Now you say, hey, you know what, could I have done the brute force? Yeah, you could have done the brute force, but I'm not going to do it. You can try doing brute force. You can put P in there and simplify this guy, and then put P in there and simplify this guy, and then put P in there and then square that guy, multiply with that, and divide by that, and you should get the same answer. Okay. All right. That. So what is this thing trying to test here? It's trying to test some things like, can you get to the power here? Like IV. Do you remember formula for power? So you can go from V into IV, so you can go into power there. Another place to try to remember is, do you remember rho equals 1 over sigma? And do you remember this resistance formula? So you can actually make sigma come out of there. And then it's trying to test if you remember this formula for the heat conducted through a bar. Okay. So these are the things it's trying to test. in this problem. So as long as you remember and you can manipulate form symbols through it, symbols of units through it, and don't confuse T for temperature versus T for time. So that's why I try to use little t for time. So I don't just get into t for temperature, because sometimes you have to write like this in from a memory, and then say, "Oh, that's temperature or time." So that's a place that can be a little bit problematic. Other than that, this is pretty straightforward question, and you should get it, because I think when you prepare for this test, you prepare for, you know, dimensional analysis. Lots of times they ask dimensional analysis, so you should practice other things similar to that. Maybe you can make your own stuff and see what you can practice. Hey, what's S cube sigma square K kappa? What is this? What is the dimension of this guy? You can just practice things like that. The more you practice, easier it will be for you. Okay. All right. Bye.